Welcome to our Chapter 3 video, again on descriptive statistics, this time with sample data. Again, there's a example problem available there on Blackboard. Pause the video and print that out if you need to. This problem deals with the mass of students in a health class. Notice that it says that there are 20 students that are being used as data, and the class size is 250 students. That means this is sample data. It's not all of the data, it's just some of that particular class. Keying again on the word of instead of the. Once again, if you need to, pause the video and enter this data into your TI-83 calculator. Now that you've done that, just like before, you go through the same steps. The different values that you will need are, again, that sum of x, 1272, sum of the x's squared, 82,414, so 82,414. Now, for the mean of a sample data set, x bar is the notation. The formula is exactly the same. The sum of all the values divided by n. Again, reading off the calculator screen, that's 1272. In this case, that data set size was 20. Reading from the calculator screen is that 63.6. 63.6. The standard deviation is now the S rather than the sigma because it's sample data. The formula is very similar. The numerator is exactly the same. N times the sum of the x's squared minus the sum of the x's quantity squared. All of that over n times n minus 1. Substituting those values in, which again, those all come from the calculator. 20 times 82, 414, 82,414 minus 1,272 squared, all of that over 20 times 19. That particular score is 8.93. 8.93. I want to point out for the mean, that's one place value beyond the data. Our data set was to the ones column, so the mean needs to be estimated to the tenths column. The standard deviation is 2 place values beyond. Not necessarily just the thousandths, but 2 beyond whatever your data set has. The coefficient of variation, same notation, C bar. but you obviously don't have sigma or mu. It's S over X bar. And again, it's times 100% because it is a percentage of variation. It's a way to compare different values, different data sets. For this particular one, 8.93 over 63.6 times that 100% gives us a 14.0%. This is always the tenths place for your percentage, the 10th column. So that's the calculations for the descriptive statistics of a sample data set.